Hey everyone, and welcome to The Explainer. Today, we're pointing our telescopes up at the stars for something truly mind-bending. We're going to be looking deep into a cosmic structure known as Caldwell 19, or, as you might know it, the Cocoon Nebula complex. We're going to unpack this incredible structural mystery hidden out in the dark, dusty stretches of space. It's a structure that looks astonishingly familiar to us, yet it exists on a scale so massive it completely defies human comprehension.
Okay, let's dive right into this. When you picture the shape of a double helix, your mind probably goes straight to biology, right? You think of DNA, that microscopic blueprint of life, twisting and turning inside our cells. But what if I told you that this exact same twisted, intertwined shape can actually be found floating out in the deep freeze of space? And not just floating there, but acting as a massive cosmic blueprint for the birth of entirely new stars.
To really wrap our heads around this, we need to zoom out and look at the macro view of the Caldwell 19 complex. Over on the left side, you've got the brilliant, glowing Cocoon Nebula. This bright area is essentially what's called a blister cavity. It's been violently carved out by this incredibly hot, massive, energetic star known as a B0V type, which is just lighting up all the surrounding gas and dust. But I want you to look over to the right. Trailing away from that bright cocoon is this enormous dark lane. That's the northern streamer. And from our perspective here on Earth, in visible light, it literally just looks like a thick streak of nothingness, just a shadow blocking out the stars behind it.
Just to put this into perspective and ground ourselves in the scale of what we're looking at here, this entire complex sits roughly 2,600 light-years away from us, right over in the constellation of Cygnus. We are talking about an impossibly vast structure. I mean, that dark streamer alone spans about 2 degrees across our night sky. It's this massive river of interstellar material, just quietly hanging there in the cosmos.
But as astrophysics constantly reminds us, the dark, quiet places are rarely as empty as they seem. So let's jump to Section 1, the double helix in space, and uncover what's really lurking inside that dark lane.
And this brilliantly illustrates the sheer power of modern astronomy. On the left, we've got our standard optical view, that dark void we were just talking about. But on the right, we're looking at the exact same region through the sub-millimeter instruments of the Herschel Space Observatory. Now, Herschel detects the faint heat of cold dust. So suddenly, that dark, seemingly empty lane, it bursts into view as this glowing, highly complex network of cold dust and gas. It's like someone finally turned the lights on, allowing us to pierce the veil and see the dense, skeletal structure of the northern streamer. When astronomers looked really closely at these high-resolution maps, and we're talking zooming in to an unprecedented 13.5 arc-second resolution, they found something absolutely wild. The main trunk of the streamer isn't just one single thick tube of gas. It's actually made up of 2 distinct sub-filaments. Researchers call them Fla A and Fla B, and they aren't just sitting side by side. They're actively wrapping around one another, twisting and weaving in a very distinct double helix pattern. Now you might be wondering, is this just an optical illusion? Like, is it just a weird angle we're viewing it from? Well, the answer is no. Astronomers actually used molecular line data to track the physical motion of the gas itself, and they found that these 2 distinct cloud components are oscillating at velocities between 2 to 4 kilometers per second. This kinematic data, the actual literal measurement of their movement, definitively proves that these twisting subfilaments are physically connected and interacting with each other in 3D space.
So, we have this massive cosmic double helix, but why does this specific shape actually matter? Well, that brings us to Section 2, Star Formation Crossroads. Because it turns out these structures fundamentally change how and where stars are born. The direct consequence of this twisting double helix shape is that those subfilaments, Fla A and Fla B, physically intersect at multiple points along their length. And where they cross, the material overlaps. This overlapping creates these localized nodes of incredibly high density, way denser than the rest of the filament. And these dense clumps become the absolute perfect incubators for massive cores to form, which then collapse to birth young stellar objects, or YSOs. So these intersections are quite literally acting as localized star factories.
Now, what's really interesting about this slide is how clearly the mass map visualizes that exact process. If you follow the path of the double helix, you can clearly see these bright, heavy nodes highlighted right at the intersection points. The data perfectly lines up with the theory. Star formation in the northern streamer is hyperactive exactly where these 2 cosmic threads twist and cross paths. It's just incredible to see it laid out like that. So, how does a structure like this even form in the first place? Well, astrophysicists believe it's the result of something called the fray and fragment scenario. It starts with these incredibly fast, supersonic, turbulent gas flows violently colliding in space.
This massive collision compresses all that material to form a single thick main filament. But it doesn't stay stable for long. The combined forces of the cloud's own self-gravity pulling inward, plus the residual turbulent energy just shaking it all up, cause that main filament to literally fray and fragment. And the result? Exactly what we see here. Intertwined substructures emerging from the chaos, all moving together in what we call a velocity-coherent manner.
But wait, gas and dust don't just magically braid themselves into a perfect double helix entirely on their own, right? There has to be some underlying invisible framework of physics driving this whole system, holding it together and sculpting it. So what forces are actually at play here?
Let's move on to Section 3, the electric cosmos, to see how electromagnetism adds a whole new fascinating layer to this astrophysics puzzle.
You see, space is absolutely not an empty vacuum. It is actually a highly conductive web of plasma, essentially a giant soup of electrically charged particles. And because of this, vast electrical currents can and do flow straight through the cosmos. We call these Birkeland currents, named after Christian Birkeland, the scientist who first proposed them. They are force-free, field-aligned electric currents that travel massive, almost unimaginable distances through cosmic plasma.
A really foundational paper on this topic describes the physical reality of these currents beautifully. It says, the axis of a cosmic field-aligned current is wrapped with a compound helical magnetic field, suggestive of some ancient Roman fasces. Now, if you don't know what a fasces is, just imagine a tightly bound bundle of wooden rods. As these vast electric currents flow through the plasma of space, they generate their very own swirling, twisting magnetic fields. And here is the absolute key takeaway. These twisting magnetic fields physically scavenge, drag, and sculpt even unionized dust into the exact twisted, helical shapes we're observing right now in the northern streamer.
So, the crucial point here is understanding the difference and the teamwork between magnetic fields and electric currents. Studies of the IC 5146 streamer show uniform magnetic fields running perpendicular to the filament, which basically helps support the entire structure so it doesn't just collapse under its own gravity. But remember, magnetic fields don't just exist in isolation, they are caused by electric currents. It is the underlying electric currents flowing through the plasma that actually generate and actively shape those magnetic fields.
To quickly summarize the high-energy physics going on here, let's look at how these forces interact. The uniform magnetic fields act kind of like a skeleton, running perpendicular to the streamer to prevent it from just caving in on itself. Meanwhile, at the very edges of the filament, we observe the magnetic fields bending, which causes what astronomers call edge-dominated collapse. And, weaving through all of this, you have the electric Birkeland currents creating that helical magnetic wrapping, scavenging matter and literally dragging it into those dense, twisted nodes to fire up the stellar nurseries we observe. It's a remarkably dynamic system.
Which leaves us with a truly staggering thought to wrap up on. If the vast, seemingly empty vacuum of space is actually an active, invisible electrical web, a web capable of twisting colossal rivers of gas into double helices and holding together entire star-forming factories like Caldwell 19, well, what else are we entirely missing out there in the dark? The universe is clearly far more connected and far more electric than we ever imagined. Thank you so much for joining me for this explainer. Until next time, keep looking up.